Hi, so you guys have done your projects on atomic structure, and there were just a few background points that I wanted to make sure that you knew. And so as you're watching this video, you may want to fill in some notes on the guided notes that I provided for you. And here we go. Okay, so we're going to be looking at the early models of the atom very quickly. And so first of all, what is an atom and what's the definition of an atom? And the definition is it's the smallest particle of an element that retains its identity in a chemical reaction. So that's the definition of an atom. And the first idea of atoms came about from Democritus, and he was a Greek philosopher, and he believed that matter was discontinuous. And that meant that there came a point when matter could no longer be subdivided any farther, that there was a building block of all matter, and he called it atomos, meaning indivisible, and he believed that atoms were indivisible and indestructible. So he's really the first person in history who was suggesting the existence of atoms. And then it wasn't until John Dalton, a school teacher in England, who resurrected this idea. He transformed these ideas, and what he did is he came up with Dalton's atomic theory. Now, these are the postulates of his theory, and we'll find out in this unit that not all of these postulates are 100% accurate, and we'll talk about that when we get to them. But Dalton felt that all elements are made of indivisible particles called atoms, that atoms of the same element are identical, that atoms of different elements can combine in whole number ratios to form compounds, and that chemical reactions happen when atoms are joined. Now, I just wanted to throw in here something about atomic size. Atoms, we say, are very, very small, and so what unit of measurement that's typically used for measuring atomic size is called angstroms. And it's really not a unit we use much anywhere else, but angstrom, in case in your reading you start seeing the word angstrom or this symbol, it's an A with a circle on top, and angstrom is 1 × 10 to the -10th meters. And the radii of most atoms are somewhere between 1/2 of an angstrom to 2 angstroms. So again, we knew that they were tiny. They're so tiny, but can we see them? Well, if you're using the scanning tunneling microscope, you can, and we saw a video about that in class. All right, so atoms are the basic unit of an element, and they're made up of smaller subatomic particles, the protons, the neutrons, and the electrons. And so you have heard your classmates talk about how these subatomic particles were discovered. If you need more reference videos, if you didn't quite gather everything, I have linked 3 really good videos in today's homework where you can hear someone else talk about how the electrons, the protons, and the neutrons were discovered. And throughout all of this, I want you to see this major theme that we're going to see in chemistry this year. We're going to see it in this unit and throughout the whole year. And it's that opposite charges attract. So a negative charge is going to be attracted to a positive charge. And like charges repel. So a positive charge will repel another positive charge, and a negative charge will repel another negative charge. Now we see this with the gold foil experiment with those alpha particles repelling against the positive nucleus. We see this with Thomson's experiment when the negative electrons are attracted to a positive charge. So again, this is a major theme in chemistry, and you should just always kind of have it in the back of your mind. All right, now, radioactivity was used to discover the protons and the neutrons. And because of that, I just wanted to give you a little bit of a background about radioactivity, just enough so that in this unit it will make sense. So Becquerel was the first person who was credited with discovering radioactivity, and he was discovering rays from uranium was exposing his photographic film. And these rays were just spontaneously emitted from the uranium. Marie Curie named these rays radioactivity which she said meant spontaneous emission of particles. And she said that elements that emit these rays are called radioactive. So here are the types of radioactive rays. There are alpha particles, and the Greek letter for alpha is this. And so sometimes you'll see it drawn like that. These are positively charged particles, and that's important to know. Of the radioactive rays we're going to talk about, the alpha particles have the lowest energy. Now, they're made up of 2 protons and 2 neutrons. So essentially, an alpha particle is the same thing as a helium nucleus. So you may see it written like this as well. So 2 protons and 2 neutrons. This is the size of an alpha particle. Beta particles have a negative charge, and they're basically electrons, so they have very little mass. They have a lot more energy than alpha rays. If you wanted to block beta emitters, you would need some thick plastic to block these rays. And beta particles sometimes are written with the Greek letter beta, or you can see them represented with an E with a negative charge, meaning, well, they're negatively charged and they're electrons. They're very light, high energy radioactive rays. And then there are gamma rays, and gamma rays have no charge at all. They have the highest energy, and so when the neutrons were first discovered, they thought that possibly it was gamma rays, but they found out that this particle that was being emitted when they bombarded beryllium with alpha particles, some radiation was given off that had no charge, but the particle had a lot more mass than a gamma ray, and then they found out it was a neutron. But anyway, gamma rays have no charge, and they have the highest energy of all of the radioactive rays. So the lowest energy and the largest particle are alpha particles. So they are the biggest, and then the gamma rays have the highest energy. All right, now when we're all done with this history unit, this is what I really want you to come away with, besides understanding those very elegant experiments which led to the discovery of the proton, electron, and neutron. But first of all, the electron's mass is very, very small. It's about 2,000 times smaller than the proton and the neutron. And notice the proton and the neutron are very similar in mass. The neutron is just slightly larger or more. It has a slightly larger mass than the proton. So electrons essentially have no mass when you compare them to the proton and the neutron. Proton and neutron is essentially the same mass. The neutron is just slightly heavier. Electrons have a negative charge, protons have a positive charge, and neutrons have no charge. So when you're all done with this unit, I want you to make sure for going on to the next unit, this is the knowledge that you need to move forward. All right. Well, have a good night.